All right, so if I drew the number line, put -2 here, -3, -4, -1, is this gonna be an open or closed circle on the -2? Closed, and we're gonna shade it to the left. So if I'm writing this, this will be negative infinity this way. I'm gonna write that first, negative infinity, gonna be a parentheses there. And is this one gonna have a, to -2, is this gonna have a bracket or a parentheses? Bracket, good job. Okay, all right, everybody good on this? Any questions on integral notation? Again, there's a whole folder on this with videos. So if you need some more additional help on that, please check that out for this week online, okay? All right, so we're gonna go ahead and do our notes for 1.6. And that covers just problem solving techniques. Again, I can't cover every possible word problem that there is, but there's some, I'm gonna do some. There's a lot more problems in your book. Interest, there's mixture problems, motion, constant. All right, so let's look. I'm just going to do some examples with you guys, and these are going to take a little bit longer to write up, so just bear with me. All right. So suppose that they borrow $600 for 6 months at a simple interest rate of 10% per annum. What is the interest that they will be charged on the loan, and how much does Jose owe after 6 months? All right, so if you think about this with word problems, it's important to read it a couple times, figure out what is important, what is the question asking for. We're talking about the key here is simple interest rate. And there's a formula that you probably learned for simple interest rate. It's also listed in your book. And that formula is the interest is equal to your principal times your rate times your time. Time is always in years. Okay, rate is the percent, okay, and you always have to put that as a decimal. And then your principal is what you're borrowing, or what you're putting into the bank, either one of those, okay? So what's important here, he borrows $600 for 6 months, that's the time here, and at a simple interest rate of 10%, okay? So we have our 3 things that we need, and we want to find what is the interest, and we also want to figure out how much is does he owe after 6 months? So what is the total amount that he has to pay back, okay? So what would our P be here? What would our R be here? And what would our time be here? Okay, so that's what we gotta figure out. What would P be? Anybody know? Okay, $600 would be our P. What about our rate? Our rate, we know, is our percent, which we see here is 10%, but I need to write this as a decimal. So if you think about 10%, it would be, move our decimal 2 places to the left, which would be 0.1, very good, or 0.10, say that as well. And then our time here is 6 months, but remember time is out of a year. So if you think about 6 months, very good, it would be 0.5 because it's really technically 6 out of 12. This is the most people miss this question all the time because of this. They put 6 for time, but that would be 6 years. Okay, this we're talking about 6 months. 6 out of 12 is equal to 1/2 or 0.5. So we're going to put 0.5 here. And now we can figure out our interest by multiplying 600 times 0.10 times 0.5. Somebody tell me what you get there. Should get 30. Very good. Okay. That means that you're gonna have to pay back $30 in interest if you borrow that amount for 6 months at a 10% per annum. That means per year. Okay. So that's the first part of the question. What is the interest you will be charged? And then how much does they owe after 6 months? What are you gonna have to do to figure out the total amount? What would you do? Okay, that we're not gonna add anything to point, for the time. What you would do is you would take the amount of interest we have to pay and the amount that you borrowed, and so that would be total amounts. So you would say 600 plus the interest, so you would owe $630 for the total amount. Does that make sense? So 600 plus the interest would be the total. Okay, questions on that one? Again, I'm just gonna try to do several different problems, just to kind of give you guys an idea. I can't do every example, but, all right, here's another one that a lot of people have trouble with. All right, so Candy has not $70,000. That looks like 170, sorry, guys. 70 here, okay? $70,000 to invest and wants an annual return of 2,800. Okay, so she wants to make 2,800, which requires overall rate of return of 4%. Okay, she can invest in a CD, but it pays only 2%. And to obtain 4%, she agrees to invest some of the money in bonds that are paying 7%. How much should she place in each investment to achieve her goal? Okay. So if you think about this, there's some information here that really isn't needed. If you're taking 4% of what she's investing, what would you get? Think about that. If you take 4% of what she's investing, which is $70,000, okay, 70,000 times 4%, what would I do? What would I do there? 2,800, okay? So really, this 4% is not necessary because it already tells you that we're getting the 28%. So really, you don't need to use this 4% at all. You get 2,800, which is what we've already figured out that we want to get a annual return on. So you're taking this 70,000 and you're putting some of it into a CD and you're putting some of it into a bond, okay? And you want to make 2,800 off of that. You want an annual return of 2,800, okay? So how do we calculate? How do we figure out what goes in each of these? We know that how much of this that we're getting, okay, it pays 2%. So this one pays 2% and this one pays 7%, okay? So what we do is we figure out what variables are we going to represent. Do we know how much is going into each of these? No, that's what we're trying to figure out. So what we would do is we would take 2% and we would multiply it by X because we don't know how much is going into this one. And then, and again, we're having 70,000 to invest. How do I figure out what this one's going to be? We know we're paying 7%, okay? We get 7% of this. How do I figure out what this would be? So hypothetically, let's just say of the 70,000, let's say I just randomly put 40,000 in this one. How much would you put into this one? Not 2,800. 2,800 is what we're trying to get at the end. Okay, we're having 70,000 to invest. Okay. Think about this kind of like interest, right? You put money into certain things like CDs or bonds or stock, like you can make interest off it. Yes. So Riley, you're right. 30,000 would be what you would have putting in this one. Now, how did you get that? You subtract from 70, right? From the 70,000. So let's say I put 20,000 in this one. How much would you put into the bond? 50,000. Does that make sense? But we don't know how much we're putting into the CD. So what we would do here is what we're saying here, to find this amount is you take the 70,000 and you subtract it by whatever you put in this one, which is going to be X. Does that make sense? Does everybody understand this? This is what's a little bit complicated. We don't know how much we're putting in the CD, but we know whatever is left over from that amount goes into the bond. So we're going to let X be the amount that we put into the CD, and then 70,000 minus X, that's what's going to go into the bond. Does everybody understand that? So this is our equation, okay? Now, we don't usually let 2%, we would write this as 0.02 times X plus 0.07 times 70,000 minus X is equal to our 2,800. And then you solve this linear equation and we can figure out, okay, how much is going to go into the CD? how much is gonna go into the bond for us to get the return of 2,800. Okay, so let's finish solving this. We would have to distribute, so 7% of 70,000 is going to be, what is that? 7% of 70,000. $4,900 minus 0.07x plus 0.02x equals 2,800. All right, then I have these two. That's gonna be what, negative 0.05x plus 4,900 equals 2,800. Okay. And we subtract 4,900. And then divide, it's gonna be a negative, obviously. I should do that. All right, so negative 0.05x is equal to negative. That's 100, is that right? Check my math there. And then you should end up with 28,000, right? I don't have my calculator with me. Oh, 42,000, sorry. So this negative 2,100 divided by negative 0.05 is 42,000. Okay, so 42,000 would go into the CD, and therefore, how much would go into the bond? So this is the CD. How much would go into the bond? You would take the 70,000, subtract the 4,200, and that would be the 28,000. That's where I got that earlier. Okay. And so if you calculate this, if you add these two together, they're going to give you the 70,000, okay? And it also gives you the 2,800, and you do the 2% of this, and the 7% of this will give you the 2,800. Any questions on this one? A little bit more complicated money problem. All right, let's look at a mixture problem. Or blending problem, sometimes they're called. Mixture or blending. So there's a method that you can use, it's called the bucket method. So it kind of looks like this. You always have what you start with. And then you multiply that by how much money it is, or the percent, okay? Plus what you add in times the money or percent is equal to the end result or mixture times your money or percent. So I'll write an example one time. All right, how many pounds of coffee worth $1 per pound must be mixed with 15 pounds of coffee worth $1.60 per pound to obtain a blend worth $1.20 per pound? Okay, so this is kind of a blending one. So if you use the bucket method, you can look at, okay, how many pounds of coffee worth $1 per pound? So this is what we're starting with. We don't know how many pounds. So what would we let go in this box here? We don't know how many pounds of coffee that are worth $1 per pound. So this is going to be $1 on the bottom, and we don't know how many pounds that is. So that's going to be X. Plus, we're mixing it with 15 pounds of some kind of coffee. So 15 goes here, and that's going to be worth $1.60 per pound. This is 15 pounds. And we don't know how many pounds in this one. And then it's blended together. So that means the X plus the 15 to give you $1.20 per pound. Does that make sense how I use the bucket method? So we don't know how many we start with in this coffee, and it's $1 per pound. The next one is mixed with 15 pounds of coffee worth is $1.60. And that's going to be equal to them blended together, which will be X plus 15, and that's for $1.20. So to write our linear equation, we will literally multiply each of these. So this will be 1 times X plus 15 times 160 is equal to 120 times X plus 15. Okay. And then we do that 15 times 160. And when we finish solving that all out, you should end up with 30. Not going to work it all the way out just because we've got several other problems. Maybe one more problem. Try to get to one more problem. Okay, so when you do that one, you should get 30 pounds is blended for the first part. Okay, questions on that one? All right, let's do another one, but a mixture problem this time. How much water must be added to 14 ounces of 20% alcohol solution to obtain a 7% alcohol solution? Give y'all a second, write that down. All right, so you think about this when you're adding water to a alcohol solution and you don't know how much water must be added, and you're adding it to 14 ounces of a 20% alcohol solution, and you want to obtain 7% alcohol solution. Okay, so we don't know how much water, so that's going to be X. Okay, and we're talking about water being added to a alcohol solution. So what would be the percentage? What percent are we thinking of here? We're talking about an alcohol solution. So does anybody would be 20% because 20% is with the 14 ounces, okay? We're mixing it with 14 ounce, okay, of 20%. And it would be 7% because 7% is our mixture here. 7% would go on the end, and we're combining these two. Think about you're adding water to an alcohol solution. So what would be the percentage of alcohol for a water solution? Is there any alcohol in water? No. So what would that be? 0, right? So this will be 0%. Okay. How much water must be added to 14 ounces of a 20% alcohol solution to contain a 7% alcohol solution? So you don't know the amount of water, but it's going to be 0% of the alcohol solution. 14 ounces of 20% alcohol solution. And then we have X plus 14 would be our blended 2, and we have 7%. Okay, so we're going to multiply each of these. So 0 times X plus 14 times 0.20 is equal to 0.07 times X plus 14. That goes away, and you should end up with 26 when you solve all that out. It would be 0.07. This would be plus 0.98. 2.8, so we have what, 2.8 equals 0.07x plus 0.98. So what we would do is move this over. Eight minus. That's 1.82 equals 0.07x, and then the last thing is divide, and you get 26. Okay. So I did examples of mixture blending. The only ones that I didn't really cover are the motion and constant rate jobs. But there's several examples in the book. There's some same, I mean, again, there's a million different types of equations that we could do for word problems. The key is just kind of be able to understand what the question is asking for, and then picking out what's important and what's needed, and then writing your equation for it. Okay. Are there any questions before I let you guys go? We finished a couple minutes early. Again, this week's is going to be due on Sunday, so remember that. You have a quiz on 1.5 and 1.6, a quiz on integral notation, and then a chapter 1 review. So that kind of goes over everything in chapter 1. So obviously, get your 1.5, 1.6 done first, then review over your chapter 1. I also posted a practice test for chapter 1 if you just want to practice that before you do your chapter 1 review quiz. And then the integral notation as well. Okay. I wouldn't wait until Sunday to get it done, and go ahead and start working on it now, and maybe get them all done. So I've covered everything now for that. And then next week, like I said, we'll have 2 weeks to do it, or almost 2 weeks to do it. Not quite exactly 2 weeks, but close to it. And you guys can go ahead and work over spring break if you want to. If you don't, you can wait until that weekend and finish it on Tuesday, that next Tuesday on the 21st. Okay. If you think of a question, shoot me an email. I'll probably still check my email over spring break at least once, twice. My daughter's having surgery next week, so we'll see how that goes. But anyway. All right, well, you guys have a wonderful break, and shoot me a question if you think of something. Thank you.